In the last episode, we talked about how serendipity often emerges inside a single mind. We looked at how altering between deep work and mental drift, focus and wandering, can allow unexpected ideas to connect. Sometimes the insight arrives during a walk, during daydreaming, or even in that strange half awake moment just before sleep. But today, we're looking at another side of serendipity. Because sometimes the unexpected connection doesn't arise within a single mind at all. It emerges when ideas collide across people. In other words, serendipity can be social. Instead of the penny dropping inside one mind, it happens between minds. A conversation, a disagreement, or a question from someone outside your field can trigger a connection that might never have appeared in isolation. Curiosity begins early. You can actually see this process very clearly in children. Young kids often ask questions like, why is the sky blue? What happens if we mix these colors? Why do leaves fall? Children are naturally curious. That questioning instinct is essentially early scientific thinking. So the challenge for kids isn't creating curiosity. The real challenge is not accidentally suppressing it. Learning environments play a huge role here. Several aspects of how we structure our education and collaboration can make a big difference. One simple example is rewarding questions, not just answers. Many classrooms emphasize getting the correct answer, but curiosity grows when questions themselves are valued. When people feel comfortable asking questions, even simple or naive ones, new lines of thinking begin to open. And importantly, this principle is not limited to childhood. It applies at every stage of life. In universities, unexpected connections often appear when disciplines overlap. A computer science student sitting in a philosophy class might suddenly begin thinking about the ethical implications of algorithms in a completely new way. The physical environment in universities can also influence this process. Shared common areas, interdisciplinary buildings, and libraries that mix books from different fields, all of which increase the chances of serendipitous encounters. Even shared research spaces can matter. Instead of isolated department silos, mixed research environments allow spontaneous intellectual exchanges. A short conversation between researchers from different backgrounds can introduce perspectives that neither person had considered before. The same idea applies to conferences. Beyond the formal presentations, conferences often create spaces specifically designed for intellectual exchange. Poster sessions, for example, allow researchers to present ideas in a more interactive format. But their impact depends on how seriously they are treated. When conferences actively encourage people to attend poster sessions and engage with presenters, those spaces can become fertile ground for unexpected connections. Some conferences also experiment with co-building round tables where participants collectively develop ideas rather than simply presenting finished work. These formats encourage participants to interact across disciplines and perspectives, which increases the chances of serendipitous insight. Even the way research is communicated can shape these connections, and publishers play a huge role in this. They increasingly encourage graphical abstracts, for instance, clearer explanations of research, and more accessibility. When we have to place ourselves in the target reader's shoes to understand which format works best for them, this also forces us to think of our manuscript or our study from different perspectives. Now let's address the elephant in the room. What's in it for us? So what does this mean for how knowledge actually advances? One of the most important ingredients in discovery is something that might sound uncomfortable at first: intellectual friction. Debate, disagreement, and criticism can actually strengthen ideas rather than weaken them. So the next time you feel shy of expressing your views to your peers, remember how well this worked in the past. One famous example comes from the debates between Einstein and Niels Bohr. Einstein was deeply uncomfortable with the probabilistic nature of quantum mechanics. He famously argued that the theory must be incomplete. Bohr, however, defended the emerging interpretation of quantum theory. Their debates were intense and often philosophical, but they forced physicists to examine the foundations of quantum mechanics far more rigorously. As a result, researchers began exploring the implications of the theory more deeply. Over time, this led to the investigation of phenomena like quantum entanglement. Decades later, those same ideas would become central to quantum computing and information theory. The disagreement did not stop progress. If anything, it sharpened the questions. Another famous example involved tension and competition between researchers studying DNA. Scientists including Rosalind Franklin, James Watson, and Francis Crick were all trying to understand the structure of the molecule. Franklin's X-ray diffraction data challenged earlier structural assumptions about DNA. Her work forced other researchers to rethink their models. The competing interpretations and pressure to explain the data ultimately helped reveal the double helix structure of DNA. Once again, the key ingredient wasn't smooth agreement. It was intellectual friction. The push and pull between different perspectives helped bring the underlying structure into focus. So sometimes serendipity happens when ideas wander inside our mind, but sometimes it happens between people through disagreement, collaboration, or a fresh perspective from someone outside our usual circle. Even something as simple as a conversation with a peer can trigger an unexpected insight. A discussion over coffee with a colleague might suddenly connect two ideas that previously seemed unrelated. But what about our latest peer? One that doesn't think much about the taste of coffee at all. In the next episode, we're going to explore serendipity in the age of AI and algorithms.